All right, if we take a look at example 3, we have a chord FH and line HJ, which is tangent to circle E at point H. So that's, we're given some stuff here, and so kind of a lot of stuff condensed into one little statement there. But recall that a chord is a segment that attaches from the edge of the circle across the circle to the other edge of the circle, not necessarily through the center. All right, so FH is a chord, not a diameter. DH does pass through the center, and I know it's circle E, so I know E is the center. So when they name the circle, we know what the center is. So if you have a chord passing through the center, that's a diameter. So be recognizing diameters when you see them. And we're told that we have this line HJ, which is tangent to circle E at point H. So point H is on the circle. Everything else on the line HJ does not touch the circle. And the chord and the tangent meet at point H as well. So what they want to figure out any relationship between angle FHJ and arc FGH. Just like yesterday when we were trying to find relationships and things, I use different letters to represent these. It's easier to work with a single letter than it is to work with these. So I'm going to assume some relationship between the measures of these things. It's typically arcs have an angular measure, angles have an angular measure, arcs have a length, angles don't have a length. So if there's any relationship, it's probably about angle measure rather than anything. So I'm going to say let X is going to represent the measure of angle FHJ. And we'll let Y represent the measure of arc FGH. And really I could have called it FH if I wanted to because it is a short distance, but we'll just go ahead and go with FGH because that's what they said. So this little bit here is X, and from here around the circle to here is Y. All right. Now, looking at this picture, first thing, again, they've drawn in this diameter HD. Had they not drawn in the diameter HD, I might have wanted to draw in the diameter HD, just to get something set in stone. A diameter cuts a circle in half. So if I just threw in a couple extra pieces of information, this right here, this angle, since we have a right angle happening where the radius meets the tangent, this is X, this little angle left over here has got to be 90 minus X. Okay, using the relationships we found yesterday, angle FHD is an inscribed angle in the circle. We're calling an inscribed angle, it has a vertex sitting on the edge of the circle. And inscribed angle is half the measure of its intercepted arc. So FD, elbow moved it, FD, the intercepted arc for the inscribed angle FHD, should be double in size of this angle. So FD would be 2 times 90 minus X. Again, I'm looking for a relationship between these two values, so what I'm trying to do is I'm trying to create an equation containing both X and Y, the things we're trying to find the relationship in. So as I identify things, I'm just kind of walking around the picture here. This is X. I'm continuing to try to use the letter X to represent different things in the picture, or I could have done the same thing with Y. Now, finally, if I start at D and walk around the circle all the way to H, since DH, segment DH is a diameter, arc DH is half a circle or a semicircle. So the entire measure of arc DH is going to be 180 degrees. So I know that the two arcs, specifically Y and 2 times 90 minus X, those two arcs have to have the measure of 180. So if I write an equation, it's going to look like this. Y plus 2 times 90 minus X is equal to 180. And again, I'm looking for a relationship between these two things. At this point, I've got X and Y in the same equation. So my final thing I'm going to do is I'm going to solve for Y, solve for X, take your pick. Get to say Y equals everything else or X equals everything else. First step in solving anything is simplification. 2 times 90 minus X, distributive property, is going to get me Y plus 180 minus 2X equals 180. I know I've mentioned this multiple times, but I'm going to say it one more time. If you're in an equation, you have the exact same object on both sides of the equation, they can cancel. No matter if it's letters, numbers, anything. So in essence, I subtracted 180 from both sides. That left a 0 on the right-hand side. So all I have to do to get this, say, y equals, is move the 2x to the right. So chop the 2x, move it to the right, and all of a sudden I get y equals 2x. If I divide both sides by 2, 1/2 times y equals 1x. Two relationships that are very much like the relationships we saw yesterday. The arc is twice the angle is half the arc. Take your pick on how you want to look at it. The relationship here is the same. All right, x is the angle, y is the arc. The arc is twice the angle is half the arc. So if I'm writing a relationship, I want to go back to these notations. I'm going to say the measure of arc FGH is equal to 2 times the measure of the angle FHJ, or the angle, measure of angle FHJ equals 1/2 the measure of the arc FGH. Going back to this picture, because again, I want you to be able to generalize this for the sake of being able to do this stuff. What I'm looking at here, I'm going to erase all my markings on my picture so we can really look at this. Focus on these problems and recognize relationships here. FHJ is formed by the chord and the tangent. Again, pretend the diameter's not there. If I see a chord and a tangent, it creates both an angle and it creates an arc. The angle is half the arc is twice the angle. That's what we're focusing on there. So that's the relationship, that's how we want to deal with that.